All right, welcome to chapter 3. This chapter is very science-based, and I always post a study guide in the modules to help you guide your studying to study for exams. I'm skipping the first half of this chapter because it's very chemistry-based, and I love chemistry. I was a chemistry major, but I'm going to skip that half of it. But you guys should work through it and answer the study guide questions and be familiar with atoms and how they're made up. But I'm going to start here because this is a very long chapter and I want you guys to try to listen to it as best you can. We're going to start kind of right in the middle of the PowerPoint with talking about the Earth's structure. The core is made of nickel and iron. It has a solid inner core, a liquid outer core, and the currents in this liquid core produce a magnetic field. The mantle is above the core. This makes up 70% of the Earth's volume. The crust is the only part that directs with living systems, and that's where kind of we come into play and all the ecosystems are. The lithosphere is the crust in the upper part of the mantle that interacts with it. This is a look how a long time ago, there's a theory that all the continents were connected, and it's a pretty good theory, I think, because if you see here, South America fits nicely into Africa, and some sort of event allowed these continents to separate. So you can kind of fit some of the continents together like a puzzle. And this is the Earth's structure and how it's laid out. The continents are moving, and this is what we call the crust part of the structure is slowly moving past each other. And tectonic plates are pieces of the crust that float on the mantle. Continents are embedded in the plates, that should say continents. And you can see here where the divergent boundaries of the plates are. And this plate boundary and the movement of these tectonic plates next to each other is a common place where earthquakes can occur. And you can see in Southern California, the San Andreas Fault, we're really near one of those fault lines or the boundaries between those plates. So this is just an example showing how these tectonic plates move past each other. They meet at the boundaries, which can be divergent or convergent. And this is a look at how these tectonic plates are actually moving past each other in the direction of those arrows. The rock cycle leads to a wide variety of rocks: igneous, sedimentary, and metamorphic. And you should know these three major rock types, and you can read through the different types of rocks there. The biosphere are all organisms and non-living environments, and the biogeochemical cycle is all flow of matter through the ecosystem. The main elements involved here are carbon, nitrogen, and the compounds are water. And this cycle has different pools where the matter resides. And here's a main look at this biogeochemical cycle. There's 25 major nutrient elements needed for life processes. There's macronutrients and micronutrients. This is a great example in video taking you through that. The majority of our organisms, the human beings, are made up mostly of oxygen and carbon. Earth has the gravity to hold the atmosphere, and the unique atmosphere supports life. The atmosphere is mostly made up of nitrogen. So the air you breathe, we think it's oxygen, but about 78% of it is nitrogen. Oxygen makes up the next biggest part of it. Here are the layers of the atmosphere and the relative deepness or width of them as they surround the Earth itself. And you can see the layers of the atmosphere here: troposphere, stratosphere, an ozone layer, the mesosphere, thermosphere, and exosphere. You can see where the space stations and satellites, what area they will rotate and gravitate around the Earth in. Here's the aurora borealis, which are lights, can be seen in the northern hemisphere, especially in the winter time. Water in the atmosphere, water vapor is about 1% of the molecules. Vapor pressure, I'll have you look at that, and it's greater at sea level. It can range in great amounts. Saturation vapor pressure, it can be temperature dependent. Above saturation vapor pressure is when water condenses, and this will create rain and fog. And we talk about this because this will eventually get us to weather, talking about relative humidity, dew point, and how they will change over the course of the 24-hour day. The energy budget measures all energy entering and leaving the Earth. It balances over time. Solar radiation, most of it is reflected or absorbed, excuse me, by land, sea, and air, but about 30% of it is reflected back into space. And this is a look at incoming solar energy, how much is absorbed, and what gets reflected back. So then we get into weather and climate. Climate is long-term atmospheric conditions, and weather is short-term variations within that climate. Wind cells are when sunlight heats the earth unequally, and the difference causes different temperature and pressure. So air will circulate in large convection currents, and it'll influence climate. So we have intertropical convergence zones, and air will move towards the poles. So we get these convection cells flaking the equator, kind of causing these wind cells. So this is showing how sunlight hits the earth, causes these cells and wind cells to circulate and creating these convection currents. You can see how these convection currents with the Earth's rotation cause the air to flow around the globe. Ocean currents are another big play into the weather and climate. We have surface currents and vertical and deep ocean currents. This is a look at these currents. The red arrows look at warm air. So you can see how the red arrows will start around the equator, where the direct sunlight will heat that water, and the red arrows will take that warm water north and south, and then the blue arrows start from the poles and bring cold water towards the equator. So we get these currents. These are deep water currents. You can see how they travel around the globe as well. The seasons, because the Earth is tilted on an axis, this causes differential heating of the sunlight throughout the year. It causes the wind cells to shift north and south, so this will influence rainfall and temperature and cause our seasons, which this graph will show here. Climatographs depict climate. They show the months of the year on the x-axis and the patterns of temperature and precipitation on the y-axis. And we will look at climatographs a lot when we go through all the different biospheres on the Earth. So they all will show the months of the year on the x-axis and the average temperature and precipitation on the left and right y-axes. So you should be very familiar with these graphs, because we will go through these different graphs and how they're different throughout the globe. Thanks for listening to Chapter 3, and we'll see you soon for Chapter